So starting with today, using scientific notation. How comfortable are you guys with scientific notation? What's that? So not very. So if I have 6,200,000 and you're going to write it as 6.2 times 10 to the, I don't remember what I said, 10 to the 5th. How comfortable are you translating big numbers into exponent numbers? Need a refresher? Will it need a refresher? Okay. Then dimensional analysis is something that will be kind of new. We've used a little bit, but you probably didn't know it. And that's something that you will use forever in chemistry and other things. So review, quantitative means what? Numbers. It deals with numbers. 5 centimeters. Our density, if we're talking about 10 grams per milliliter, that's quantitative data. New one, scientific notation, which obviously you guys maybe didn't know exactly what it is, but it's using exponents. 10 to the negative 5th, 10 to the positive 5th. Dimensional analysis and conversion factors go together, and they will become your good friend. So, scientific notation can be used to express numbers between 1 and 10, which is the coefficient. I always call it the number in front, the coefficient, multiplied by 10 raised to an exponent. So your exponent might be a positive number and it might be a negative number. The good thing about these is they take huge numbers. So if I actually have 4.6 times 10 to the 23rd, I have 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Do you really want to write that number out? No, I just wasted 10 seconds writing that number out. Where 4.6 times 10 to the 23rd is the exact same thing. So scientific notation takes huge numbers and makes them a lot easier to write out. And in chemistry, when we're talking about atoms, we'll be working with some very big numbers. So using an exponent is much easier. So here, 4.6 is the coefficient, 10 to the 23rd is the exponent. So when we do this, where your decimal place is at will be very important. So you're going to count the number of places behind the decimal point in order to figure out what your coefficient is going to be. And then the number of the places that it moves is going to equal your exponent. Yep? Come grab a different one then. That was Abby. Abby handed them out. Did you write on that other one already? It's okay. Okay, here, this part right here is important. The exponent is positive when the decimal moves to the left, and it's negative when the decimal moves to the right. So there's a couple of things that you're going to want to remember. If I have a big number, you're going to have a positive exponent. If I have a decimal number, a small something less than 1, you're going to have a negative exponent. So if I look at 800, right now as 800, where is my decimal place at? It's at the end of it. So if I'm going to write that in scientific notation, I always want one number. So I don't want 80 times something. I always want one number in front of my decimal. So I'm going to move my decimal here. So I'm moving it 2 places. So I'm going to write 8 times 10. How many places did I move it? 2. So it's 8 times 10 to the second. It's a big number. I know that when I move to the left, basically I know it's a big number, it's a positive exponent. Here I have a very small number. I still want to move it to one number in front of the decimal. So I notice that I'm going to put it after my first real number, which is 3. So now I'm moving my decimal 1, 2, 3, 4, 5 places. It's going to be a negative fifth because I moved the decimal to the right, or because it's less than 1, it's a very small number. So simply counting how far you're moving your decimals and then writing it as an exponent. So when we do that, we're also going to have to add and subtract numbers that have exponents. In order to do that correctly, we want to make them the same. So if I have 2.840 times 10 to the 18th, and I have something times 10 to the 17th, the exponents aren't the same. I can't just simply put them together without changing it a little bit. So you're going to rewrite one of them. It really doesn't matter which way you want to go. So here, the example that I'm using, I'm keeping this to the 18th. If I'm going to change this to the 18th, my decimal goes 1 to the left. So now I add 2.840 plus 0.360, and I am going to get 3.2. This should be an 18. That's a typo. So I'm going to add this, and I'm going to get that. And when I add, my exponent stays the same. It's not going to change at all. So addition and subtraction will be a little bit different than when we multiply and divide. So, a couple of examples. Diameter of the sun, 1,392,000 kilometers. Rule, I'm going to write a number. What's my first number? 1. I'm going to put a decimal. And then I'm going to put the rest of my numbers that are not zeros. Okay? In this, where is my decimal always at? The end. So I moved it from there to here. 1, 2, 3, 4, 5, 6. This is going to be 10 to the 6. Positive 6. I'm moving my decimal to the left. It's a big number. It's a positive exponent. Next one, the density of the sun is very, very low. What's the first number that I see that's not a 0? 2. So now I'm going to put 2.8. My decimal's here. I am moving it 1, 2, 3, 4, 5, 6, 7, 8 places. I'm going to take it times 10 to the negative 8. It's a small number. I moved it to the right. It's going to be a negative exponent. On your Connect website, there is a little tutor. You can come back and watch this again. You can do more practice. There's also a tutor spot that you can look at. And on your notes, this is important. Your two values, one is much bigger than 1. The other is much smaller in 1. They're both going to have a coefficient, and they're both going to have 10 to an exponent. And we've gone through all of that. I've showed you all that. We're good. Everybody good with that? Evaluate the answer. You should always check because the density is so low. You know the exponent is negative. Because the sun was so big, you knew it was going to be a positive. So, does not talk about subtracting. To subtract, you'll do the same thing. You have to change it to the same. So if I had, I'll pick something a little, let's say I have 5 times 10 to the 5th, and I want to subtract 4 let's do 0.4 times 10 to the 7th. Okay? Which one do you want to keep, the 5 or the 7? Which one? I don't care. 5. Okay? So I'm going to have 5 times 10 to the 5th minus something times 10 to the 5th. So if I'm going to go to the 5th, which way am I moving my decimal, right or left? So if I take out your calculators, here's a good way to double check things. Take 0.4 times 10 to the 7th. 4 million. Somebody else agree? Yep. Okay. So what will I have times 10 to the 5th if I am using my 4? I'm going to have, should be 40. Did you guys say move it to the right? I don't remember what you guys even said. So I'm going to move my decimal to the right. So now on your calculator, take 40 times 10 to the 5th. And you should get the same answer. Yep. So now I can take 5 minus 40. So you're going to have a negative number times whatever, times 10 to the 5th. Probably not a very good example because I'm usually going to have a larger integer in front of the larger, or in front of the smaller integer. Here, multiplying and dividing honestly is easier. It's easier to multiply and divide. You're going to take and multiply your coefficients. So I'm going to take 4.6 times 2. And then I'm going to look at my coefficients and I simply add the exponents together. So 23 minus 23 is 0, which is really just 9.2. To divide, you're going to do the same thing. 9 divided by 3. Now you're going to subtract exponents. So you're going to take 7 minus a negative 3, which gives me 3 times 10 to the 0. So there's an explanation. We'll do a couple of examples. Okay, so multiplying. Step 1, what do I do? Multiply 2 times 3. What do I get? 6. Second, what do I do with my exponents? Add them together. 5. So answer for that, 6 times 10 to the 5th. Now I'm going to divide. 9 divided by 3, 3. 8 minus negative 4, 12. So 3 times 10 to the 12th. So honestly, multiplying and dividing is a lot easier than adding and subtracting. And there's all of our work. I'm all right with all of that. Done that. And I will stop there and we'll practice for a little bit.